Okay, we're going to do expected probability again. We've got a die here. First thing we're going to talk about, they tell us in the first sentence, you roll a die. Does it say it's a weighted die or a corrupt die?
No.
So, is the probability uniform of all outcomes? How many outcomes are there on a die?
1 to 6.
1 to 6, right? You have 6 sides to a die, so you have 1, 2, 3, 4, 5, and 6. What's the probability of getting each of them?
1 to 6.
Yeah, that's right. It doesn't change. They all have the exact same probability as long as it's not some kind of weighted die, right? So this is uniform probability. Because we know we're rolling a die, it's supposedly even. If an even value shows, you get double the points. Great. So let's talk about our even numbers here. We'll highlight them. 2, 4, and 6 are even numbers. So how many points will we get if we roll a 2?
4.
Yes, let's talk about points. We get 4 points for a 2. How many for a 4?
8.
And how many for a 6?
12.
Excellent. Great. So we know that's going to be added. We'll do those in blue so we know that we're adding these values. And 12. Great. It also says that if an odd number shows, you lose triple. So 3 times the points showing. Well, how many points will we get if and let's highlight them, if a 1, 3, or 5 shows? How many points do we get if a 1 shows?
3.
Do we get 3 or?
Or we lose 3.
So we represent that as a negative value. For 3?
-9.
And for 5?
-15.
Excellent. Okay. Remember, expected probability was essentially the amount of points or value we get times the probability of that event happening. And then we continuously add this up to the last event. So how many events are there in total?
6.
There are 6 total events. So we know our n value here is going to be 6. N will be 6 in this case. So let's figure out our expected probabilities. In the first case, our number of points gotten would be -3 times what's our probability?
1 over 6.
That's right. And our second one?
4.
That's right.
Multiplied 1 over 6.
That's right.
-9. Multiplied 1 over 6.
Yep.
8 multiplied 1 over 6. And -15 multiplied 1 over 6.
And I'm going to move this over just so we have a little bit of room here. Don't mind that equal sign in the middle. And the last one?
12 over 1 over 6.
1 over 6. Excellent. Okay. Oh, we can do these as fractions. -3. Do you remember your fraction rules? All whole numbers, how do I make them a fraction?
Put a 1 in.
Yeah, and how do I multiply fractions?
Cross. Like,
Not across.
same side.
Yeah, top and bottom by each other, yeah. Usually when they say cross, they mean top by bottom. That's what they mean there, okay? So, -3 times 1?
-3 over 6.
All right, so we have -3 over 6. We'll do red as negative values. 4 times 1?
4 over 6.
So we'll do that as a blue value. 4. Next one?
-9 over 6.
Excellent.
8 over 6.
I said 8 over 6.
-15 over 6.
15 over 6.
And 12 over 6.
12 over 6. Great. All right. Let's see if we can simplify this a little. -3 plus 4 will give us 1 over 6. Right? So we have a positive value there. So I just simplified the first two. Okay. I'm going to simplify them in pairings, okay, which is fine. -9 plus 8 is what?
-1 over 6.
So -1 over 6. That's our second pairing. And our last one gives us
-3 over 6.
-3 over 6. So what this is that these guys cancel out and you get a -3 over 6 or an expected probability of -0.5. Okay. So our expected outcome is -0.5. And the second question asks you, is this game fair?
Yeah.
Why is this game fair?
Because both of them can have their same probability of getting an even number or an odd number.
Okay, but what happens when you get an odd number? Do you lose as many points as you get for getting an even number?
Yeah.
Well, what's the expected outcome here?
-0.5.
-0.5. So because the expected outcome is less than 0, 0 would be neutral. So you get the same amount of points because we are expecting to always lose points. Now, let's talk about theory here for a second, because you're right. Technically, this is a fair game. Assuming this isn't like a betting game with money. If we're just playing a game, you're right. The probabilities are identical. What's going to happen is the winning person will just have a negative value. But if this were a casino game and this were money, okay, so let's keep that in mind. If that was a casino game and every one of these was dollar values, well, every time I roll a dice or a die, I expect to lose 50 cents. This wouldn't be a fair game then to me, right? A fair game would be, well, my expected outcome is 0 every time I roll a die. I don't win any money or I don't lose any money. This is an unfair game in advantage to the casino. Okay, so this would be considered unfair in that idea. But you're right. If it's just a game being played for fun, probabilities are all the same, so technically it's a fair game. It's just the winner will most likely end up with a negative value. That's all it's kind of getting at. All right? Does that distinction make sense?
Yeah.